Hello, hello. Welcome back. We're gonna do a knock knock one. So ready? Knock knock. Yoda Lady. All right, let's get to it. We finished all this equation stuff. There's more equation stuff. We're gonna start applying it. Let's talk about travel. We'll talk about blood alcohol concentration, medication. You also use equations in finance, area volume, data, almost every subject. So just prepare yourself. There's a lot of equations and get good at them. Okay. Now we're going to talk about real quick some travel calculations. Hopefully you remember an hour is 60 minutes, 1 minute is 60 seconds. 1 kilometer is that's not supposed to happen. 1,000 meters. 1 meter is 100 centimeters, and 1 centimeter is worth 10 millimeters. Okay. Now, very common question, convert 40 kilometers per hour to meters per second. And so here's what I'm going to do. All right. So first of all, the end goal for me is I want to end up with meters per second, but I need to convert it. So the first thing I'll do is I'm going to change kilometers to meters because I can do that. So it'll be 40. And I know that there's 1,000 meters. So I'm going to times it by 1,000. Okay. So far, I haven't changed anything except from converting 40 kilometers to 40,000 meters. From here, I'm going to keep going because at this point, I know an hour is the same thing as 60 minutes. So let's find out what it would be per minute. And the way that I'm going to do that is to get from 60 minutes to 1 minute, I'm going to divide by 60. So that's exactly what I'm going to do there. And I've got a calculator on hand. 40,000 divided by 60 gives you, that's an interesting number, 666.67, and I'm just going to stick with that. So that's how many meters it is per minute, and we know that a minute is 60 seconds. And so to get from, let's try to fix that, 60 seconds. And so to get from that to a single second is we're going to do one more lot. We're going to divide it by another 60. Okay, do the same thing to the other side, divide by 60. I know I didn't write it down, but divide by 60. And what we're left with here is hopefully a nicer number. It's a little bit nicer. 11.1 meters per second. So in other words, 40 kilometers per hour, same as 11.1 meters per second. Okay, just changing units. Apologize for the lag. Now, there's also a speed, distance, time. If you're ever asked about speed, distance, time, just remember distance equals to speed multiplied by time. So there's this nice little triangle where you just kind of block out each one. If I'm looking for distance, I'll cross that out and I can see it's S times T. If I'm looking for S, I'll block out S and then I can see it's distance over time. And if I just want time, it'll be distance divided by speed. So that's just a nice way to remember your speed, distance, time ones. And then there's also this thing here that's probably a bit specific. This part here you'll need to know. So we're talking about car stopping distance. It just means how long it takes for your car to stop. Okay, it's important when it comes to safety, road safety, all that good jazz. And your total stopping distance is there's kind of like a reaction time. So how long it takes for you to realize you need to brake and your car's still traveling, and then your actual braking distance. Now they'll give you all the information you need. So for example, it'll look like this. Find the total stopping distance of a car traveling 60 kilometers per hour if the reaction time is 2.5 seconds and the braking distance is 0.01 v squared, where v is the velocity of the car. Okay, so let's talk about your reaction time because I want your total stopping distance. So let's start with the reaction time. And real quick, my reaction time, I'll call it RT, is 2.5 seconds. And I'm doing 2.5 seconds And I need to remember that I'm initially traveling 60 kilometers per hour. So similar to before, I'm going to change this into meters per second. Okay, so again, to get from hour to minute, I need to divide by 60. And to get from minute to second, I'll need to divide by 60 again. And 60 kilometers is the same as 60,000. I'll write this down here. So 60,000 meters. Okay, so divide that by 60, 60,000 divided by 60, that's a nice 1,000. So that's 1,000 meters per minute. And then to divide that again to get per second, I'll write min here so we don't get confused. And then divide that by another 60 to get meters per second. That's going to give us 16.7 meters per second. Okay, now why this is important is that's how much it is per second, but my reaction time is actually 2.5. So what I'm going to do here is I'm going to find how far I travel in 2.5 seconds. You don't have to do it this way, but if you'd like to, I'm going to keep it all in kind of one piece of working out. So how do I get from 1 second to 2.5? Well, I'm going to multiply it by 2.5. And I'm going to do the same to the other side. Now, I wrote that wrong. Times 2.5. So I do that. And I should be left with 41.7 meters. So far, my reaction time means that my car has traveled 41.7 meters. Okay, so I've done the first part. Now I just need to find the braking distance. So let's talk about our BD, braking distance. Now it says here, there's a nice little formula it tells you. The braking distance is this. So it's going to be 0.01 multiplied by velocity squared. So in other words, in this case, it's going to be, our speed was 60, and I'm going to square that. So 0.01 times 60 squared, and that's going to give me 36 meters. So my total stopping distance is going to be my braking distance, which was also my reaction time, which was 2.5 seconds, which meant I traveled 41.7 meters. And then to brake after that, there's another 36, because that's how long it took. So that gives me a total of 77.7 meters. That's how long it would have taken me to come to a complete stop. Okay. There you go. That's why hopefully we don't hit kids and stuff, but I think that's it for this lesson. I'll catch you in the next one. See you later. Bye.